All right, so we're going to look at motion in two different scenarios here. We're going to talk about motion with constant acceleration and then motion with variable acceleration. Now, if we have motion under constant acceleration, these equations of motion, which if you do physics you'll have come across, certainly apply. So the only thing, I guess the only rider or proviso is that acceleration has to be constant, okay? These rules aren't given to us these days on an exam. So if you want to use these rules, and you're certainly more than welcome to use them, you have to memorize them yourself. You have to know them yourself, which is fine in a tech active environment. You've got your notes there and you've probably got the formulas written down. Otherwise, as you'll see in the next section, we'll use integration the whole time to work our way from our acceleration rule all the way through to our position rule. So there's our rules. Just make yourself aware of them. Again, as it says there, they're not provided on the VCAR formula sheet. And in terms of solving them, list the quantities that you've got, which rule you want to use, and then away you go. So you can see there, I've just copied the little rules there to the left. So an object moving in a straight line, uniform acceleration, that's the key thing. Uniform acceleration, which means I can use my kinematics rules. Initial velocity of 12, so initial velocity is u. After t equal to 5, the final velocity is 20, which is v, and I'm looking for the acceleration a. So rule number one, v equals u plus at. Rearrange that, I get 8 on 5 meters per second squared is my acceleration, and that's constant. Okay, my initial velocity won't change. My final velocity, depending upon what time we're at, could change, but the acceleration is constant. The distance traveled in the first 5 seconds, so there's a rule for distance, S. ut plus half at squared, we pop that in, we'll end up with 80 meters. The time taken to travel a distance of 200 meters, use the same rule, solve that equal to 200. We can rearrange a little bit, get our 4/5. A half of 8 on 5, 4/5, multiply everything by 5 just to get a quadratic without the fraction, and then if we simplify that we get t squared plus 15t minus 250. Again, t equal to negative 25 is not pertinent to this, and so we get t equal to 10 seconds, all right? So the other kind of question that we tend to use our kinematics rules for quite a bit, or we can use them for, is motion with gravity, because gravity itself is constant unless we introduce, and we'll see that, some air resistance. So our particle is maybe thrown up into the ground, it's released from a cliff, it's whatever it happens to be. It's a cricket ball. Well, actually we don't throw them these days with any angle of elevation or anything like that. So there's the key things still there. We've got our gravity at 9.8 meters per second. All right, so I guess a couple of things to note. If an object is released from a moving vehicle, the initial velocity is the velocity of the vehicle. So if we drop from a hot air balloon that is rising at 6 meters per second, it's a nice example for it, means the particle initially is traveling 6 meters per second upward. Even though relative to the balloon it looks like it's falling, and then it'll slowly decelerate to 0 due to gravity, and then it'll start falling. Velocity of the projectile is equal to 0, it's at maximum height, it's always g. Okay, so when we have our examples, define which way you want to make positive. You know, sometimes if our particle is up in the air and we're dropping it, well, sometimes it makes sense to have positive acting down. So gravity is positive 9.8. In fact, it'll always make sense to do that. But I guess if we're throwing the ball in the air, gravity is acting against us, so we tend to make gravity acting as negative 9.8. So just, you know, the value of gravity in terms of its sign will vary depending upon the scenario. So in this instance, we've got a sign that's thrown vertically upwards from the top of a cliff. So I suppose I could draw a cliff here. And we've got our little particle being thrown vertically upwards. and then it's going to fall down. What's that, 25 meters? 25 meters. So there's our particle. So in this instance, I was happy to take acceleration as acting downwards. So acceleration of negative 9.8. My initial velocity, 22 meters per second. Now, where do I need to travel? The distance I'm going to travel, well, I have to end up 25 meters below my starting point. So I've decided to make my starting point 0, and the particle has to travel negative 25 meters. Okay, so if I again want to find the time it takes to reach the base, I've got distance, initial velocity, acceleration. So I'm solving for t. So if I solve this particular quadratic for t, I end up with 5.43 seconds. Okay.